When you look up at the night sky with the naked eye, you can spot several planets, bright points of light wandering slowly among the stars. Mercury, Venus, Mars, Jupiter, Saturn, all of them reveal themselves under the right conditions. All of them, except one. Neptune remains hidden, too distant, too faint, too elusive. And yet far beyond the reach of unaided human sight, Neptune is one of the most dynamic, violent, and mysterious worlds in the solar system. A planet wrapped in darkness, sculpted by extreme winds, colossal storms, and hidden internal heat, defying everything we would expect from a world so far from the sun. Today, on Cosmic Journeys, we travel to the edge of our planetary neighborhood to uncover the secrets of Neptune. Neptune is unique among the planets. It was not first seen through a telescope, but predicted by equations. After the discovery of Uranus, astronomers noticed something strange. Its orbit did not behave exactly as expected. Tiny deviations, subtle but persistent, suggested that another massive object was tugging on it from afar. In 1846, French mathematician Urbain Le Verrier calculated where this unseen planet should be. When astronomers finally turned their telescopes toward that exact region of the sky, Neptune was waiting, less than a single degree away from the predicted position. It was a triumph of human reasoning. Mathematics had revealed a world no one had ever seen. Just days later, Neptune's largest moon, Triton, was discovered, hinting that this distant planet was far more complex than anyone had imagined. Neptune is the 8th planet from the Sun, and the most distant one recognized today. On average, it orbits nearly 4.5 billion kilometers away, about 30 times farther from the Sun than Earth. At that distance, sunlight is more than 900 times dimmer than what we experience here. A spacecraft launched from Earth would take over a decade to reach Neptune, even traveling at immense speed. Because of its vast orbit, Neptune takes 165 Earth years to complete a single revolution around the Sun. Since its discovery in the 19th century, humanity has not yet witnessed a full Neptunian year. Time itself moves differently out here. Despite its remoteness, Neptune has seasons, just like Earth. Its axis is tilted by about 28 degrees, similar to Earth and Mars. This tilt causes alternating periods of sunlight and darkness across its hemispheres. But instead of lasting months, each season on Neptune lasts over 40 Earth years. Right now, the southern hemisphere is experiencing spring. As it tilts toward the distant sun, that region grows noticeably brighter, an effect that surprised astronomers. Even faint sunlight, it turns out, can reshape a world. Neptune's average atmospheric temperature is around -201 degrees Celsius, cold enough to freeze almost everything we know. And yet this frozen world hosts the fastest winds ever recorded on a planet. At the equator, winds roar westward at speeds exceeding 2,000 kilometers per hour, faster than the speed of sound on Earth. These winds move opposite to the planet's rotation, driven by forces still not fully understood. Dark bands stretch across the atmosphere, broken by massive storms that appear, disappear, and reappear elsewhere. When Voyager 2 flew past Neptune in 1989, it captured images of a colossal storm system known as the Great Dark Spot, roughly the size of Earth itself. Nearby, smaller dark storms churned through the clouds, changing shape and brightness over time. Unlike Jupiter's Great Red Spot, Neptune's storms are temporary. They form, migrate, and vanish, suggesting an atmosphere in constant upheaval. Neptune and Uranus are often called ice giants. They are similar in size, composition, and distance from the Sun. Yet Neptune is far more energetic. The key difference lies deep inside. Neptune radiates significant internal heat, more than twice the energy it receives from the Sun. Uranus, by contrast, emits very little internal heat at all. This internal warmth likely fuels Neptune's extreme winds and storms, stirring its atmosphere from below like a cosmic engine. Some scientists believe Uranus lost much of its original heat billions of years ago, possibly due to a massive collision. Neptune, untouched by such an event, still burns with hidden energy. Beneath Neptune's blue clouds lies a world of unimaginable pressure. Its atmosphere is dominated by hydrogen and helium, with traces of methane. That methane absorbs red light and reflects blue, giving Neptune its deep sapphire color. Below the atmosphere is a thick mantle composed of water, ammonia, and methane ices, not frozen like ice on Earth, but compressed into exotic, super-dense fluids. Deeper still lies the core, where pressures reach millions of times that of Earth's atmosphere. Under such conditions, methane molecules may break apart, allowing carbon atoms to bond into diamonds. Some models suggest that diamonds could form and fall like hail, sinking through the mantle, creating a strange, alien kind of diamond rain. Neptune's magnetic field is as strange as the planet itself. Instead of aligning neatly with its rotation, the magnetic field is tilted by nearly 47 degrees and offset from the planet's center. This creates a wildly asymmetric magnetosphere that shifts and twists as Neptune spins. The source of this field may lie not in the core, but in electrically conductive layers within the mantle, challenging our understanding of how planetary magnetic fields are generated. As charged particles interact with this distorted magnetic field, faint auroras form in Neptune's skies. Unlike Earth's auroras, they are weak, subtle, and spread across mid-latitudes rather than the poles. Neptune also possesses a ring system, though it is faint, thin, and difficult to detect. 5 primary rings circle the planet, composed of dark material that reflects very little light. Some sections of the rings contain bright arcs, dense clumps of particles that somehow remain stable over time. Why these arcs exist, and why they don't spread out evenly, remains one of Neptune's enduring mysteries. 14 known moons orbit Neptune, each with its own story. The largest, Triton, dominates the system. It orbits in the opposite direction of Neptune's rotation, strong evidence that it was once a wandering object captured by Neptune's gravity. Triton is larger than Pluto and possesses a thin atmosphere. When Voyager 2 passed by, it even observed geysers erupting from its surface, dark plumes rising into the sky before falling back as frozen snow. Other moons range from irregular, battered bodies to small shepherd moons that help shape Neptune's rings. Far beyond them all lie distant moons that take decades to complete a single orbit, testament to Neptune's vast gravitational influence. Neptune is a world of contradictions. Frozen, yet fiercely active. Distant, yet full of motion. Hidden, yet endlessly revealing. It marks the boundary between the familiar solar system and the vast, unknown beyond. A reminder that even in the coldest, darkest regions, nature can still surprise us. And as we continue our cosmic journeys, Neptune stands as a silent guardian at the edge of the sun's domain, waiting to be explored again.